Hello guys, good afternoon. How are you doing? Hello guys, you hear me? Hello. Hey Jameson, how are you? Good. Jack, do you hear me? Kevin?
Yeah, I can hear you all right. Can you hear me?
Yes, perfect, I hear you.
Yep, loud and clear, Professor.
Hey Kevin, okay guys, let's start. So where do we need one more, but that's okay. So let's start and let me share my screen and let's continue and hopefully we can do programs today. Okay, so let's do, I think we were going to sort something. So let's look for ID. What was the name? I think this was the one. Yeah, so we had the ID. So we have created this already. I hope to have age, and then we create gender, and then we did this one here. Why is that? ID, age, oh yeah, of course. So can you recover this one here, please, guys? So we have the ID, age, gender. Okay, so sometimes we need to sort for different reasons, guys, and for specific rows. Okay, the command we're going to use is let's call the ID, age, gender. Let's say sorted, and the command in MATLAB is sortrows, and then you put which matrix you want to do, and which column you want to use. So in this case, let's do based on 2. Right? So what I will do immediately is an ascending order based on, this is age, on age. You see, the youngest and the oldest here. This is the way you sort in ascending order. If you want to do in descending order, guys, what you do is you simply type a minus in front of the column number. Okay, so if we do that, let's call this the sorted one. And here you can see, so you have the older individual and the younger individual. Got it? Okay, so now what we need to learn is something related to relational. Share this one here. So now let's learn something about, yeah, let's talk about a couple of things. Let's talk about some commands that are going to be extremely useful. Okay, so for example, if you have two or more conditions, what you can do is you can use this one here. This one here is read AND. This line here is going to be called OR. This tilde here is going to read not equal. Remember, guys, when we work with logicals or array, this is going to mean equal. Then we are going to have something like is none, something like is inf. Okay, so these commands are going to be the ones I'm going to be using in a minute. So is inf and is empty. So these are going to be commands that we're going to be using in a minute. Okay, One command that is extremely useful, guys, also is the find command. The find command, what it will give you guys is a position in a matrix. Okay, so for example, if you create X to be equal to a matrix that is 0, 1, 2, 3, 4, and 5. Okay, so let's assume this is a matrix. Now, indeed, what you need to understand, guys, that every position, every number has a position, right? So this is position number 1 or column number 1, column number 2, 3, 4, 5, and 6. And the row, so this is the column. And remember, in this case, I have only one row, right? So for example, what is the position of this guy? Is going to be first row, fourth position, fourth column, right? Now, when you have one row, the number you're going to get is only 4. So if we want to find, for example, this one here, what I can do is imagine that I call x1, and x1 is going to be equal to find x, this matrix here, equals 3, for example. So what it will return, guys, it will return position, so that the answer of this one here is going to be 4. Right? So let's take a look to this one here, and then we're going to see how to use this in the example that we have. You have questions here? No questions?
Yeah, Professor, I had a question.
Yes, go
For
ahead.
the or symbol,
Yes.
is that just a front slash?
Yeah, is that,
on the
no. It is, in your keyboard, this one here is going to be normally located. You see the backslash here. On top of this, there is one like this. Is this one here? I think it's in the right hand above enter. Yes, you see that?
Yeah, okay, yeah. Okay, thank you.
Perfect. Okay, so now let's go and let's take a look to MATLAB. We're going to work with this in a minute, so we can keep this in memory. So what we can argue, guys, that let's do x equals, remember, I want this to be 0 to 6. Okay, so this is what I created before. And then what I want from here, for example, is I want to know what is the position. Remember, find gives you position. It's different than having a logical completely. A logical gives you 0 or 1s only. Okay, so I want to find the values or the positions when x equals 3, for example. You see? So what is this for? This 4 means the position. 1, 2, 3, 4. So this is position number 4. Got it? So imagine if you want to now check. No, I want to see. Okay, let's create another matrix. Let's create a matrix y equals a very simple one. 1, 2, 3, 4, for example. So this is my matrix. Okay, so and what I want from here, for example, is I want to find the positions where 4 appears. Right, so what I will do is y1 equals find y equals 4. Well, it tells me position 4. So remember that for MATLAB, guys, if you just give one position, it's going to be 1, 2, 3, 4. Right? It reads this way, horizontal first, goes back to the first one, and then reads like that. Right? So it's 1, 2, 3, 4. But now I want to know that exact position. I want to tell me 2, because this is 2, 2, right? Correct, guys? This is position 2, second row, second column. So for that one, what you need to do is you need to tell MATLAB, okay, I want to have the coordinates, not simply the position. And then the command is going to be the same. Here, the first one is the row. So your position number 4 is going to be located in row number 2 and column number 2. Make sense? Okay, so let's create another, just to use the relational. We're going to use the final relationals all together. So let's assume, guys, that you have, again, a equals 1 to 9. And let's assume that B equals 9 minus 1 to 1. Okay, so if you take a look to A and you take a look to B, this is A and B. Okay. Now, do you remember, guys, if you want to find the logical, the 0, 1, when something happens, so we said, okay, let's call TF equals A. Where's my larger than 4. So what will appear here, guys? Sorry, my TF equals A larger than 4. So what I'm doing here is 1. So what is going to appear in my Excel, in my MATLAB command? What will appear here? So what I'm saying, guys, is give me all the values on A that satisfy this condition, right? So satisfy means 1, non-satisfied means 0. So zeros or ones. So this is what I get. It's going to be 0, 0, 0, 1, 1, 1, 1. Got it? Now, let's take a look to what happens if I do TF1. And I will do the same, but I will, instead of using simply the logical, I will do the find. So what is this? What is the meaning of these 5, 6, 7, 8, and 9?
The position it holds in the
In the
array.
original matrix, correct? Yes, exactly that. Makes sense. So this implies that the value that satisfies the X, or A being larger than 4 is position 5, 6, 7, 8, and 9. Right? And also you can use this one here. So let's assume that I call A1, and it's going to be equal to A. And I want the values of A that satisfy this condition. So what it's going to do, MATLAB is going to do first find this part here, and it's going to give me position 5, 6, 7, 8, and 9 of A. You see? You see that, guys? So this is a way of addressing positions also. So what we can do is we can use let's use a logical one. Okay, so I want to find the values. I want to return the values that are between 4, you know, and what is the maximum value? Let's say and 7. You see, this is what I have said. This is my logical command. So it's going to satisfy. It's going to be from larger than 4. So let's do larger or equal than 4, smaller or equal than 7 from here. Make sense? Oopsie. Not like that. It's like that. So you select a piece of the equation, of a piece of the matrix. Make sense to you? Okay. Another command that is very useful, guys, is none. It is not a number. Sometimes you have a huge database and you want to find where are the NAs, and then you want to replace with something, for example, by 0. Right? In Excel, when you do that, you go to find and replace, and then you simply put the 2 values. In MATLAB, you first need to identify the positions. Once you have identified a position, you change this position with something. Okay? So let's create the following, guys. So imagine that we have X that goes from -3 to 3. And let's divide this by 3. Okay, so my X is this one here. What I will do is let's define Q equals sine of X element by element divided by X. You see, I will have a number that's going to be divided by 0. So any number divided by 0 is not a number, is non-defined, correct? So what I will do is imagine that it's a huge data set. I want to find, let's say position, not a number. So this is a name. And what I will do is I use the command is none Q. And what it'll provide is this one here. So it tells me that this position here is not a number. Imagine that you want to replace this value with a 9999. What you can do, a more efficient way of doing that, let's do Q2. What do you say? Simply Q of, what is the position? Q of is non-Q. Is going to be equal to 999. Oh. So this is the way you replace the values. Do you see that? First, I identify the position. From Q, so forget about this is the correct one. So first you identify the position where you find a NA number that belongs to Q, and then you replace it with any number. So I decided just to make it a case, replace it with QQQ, with a 9999. Make sense?
Professor, question. Are
Yes.
we gonna take some time today to go through some questions on homework one, since we couldn't have inferred?
Oh, you know what? I will do the no. I will do the graphs with the financials. Yeah, at the end I will reserve 15-20 minutes to do the graph, the graph side.
Yeah.
Okay.
Also, the 3D graph, we also cannot have seen that in the video, but yeah.
Which graphs?
The in the homework set, practice question number 11.
No, the 3D we did in last class.
Oh, right, yeah,
Yeah.
yeah. The but yes, okay. So the last one is question 17.
I don't know what is question 17. Yeah, let's take a look later about that. Yeah, let's do that. Yeah, let's do the financial side if you haven't seen it. It's good. It's good for you to know and check this one. Okay. What was I going to tell you? Yeah. Okay. So can we find the ID? Can you call the ID? Yeah. Can you call this one here? Just take a look to the data. This is original data, ID, age, gender. Okay, let's do a couple of examples. So I want you to find all individuals younger, older than, let's say, 15, and younger than, let's say, 19. And so let's find. So show me all the columns, okay? If you can find, if you can use, please, the find command. So let's use in find command, okay? Oh. For these two guys, use the find command just to get familiar with that. 2 minutes, guys. Give me 1 second. Yeah. Okay, 1 minute, guys, and then we solve this. Ready? 1 more minute, and then you start working. Who wants to do the first one? Okay, take 1 more minute, and then we start solving. Okay, who wants to do the first one? Someone? Jameson, Ryan?
I can go if you want me to.
Okay, Kevin. All yours.
Did you?
Yep, you have it.
Okay, cool. So I'm gonna go ahead and do this in 2 parts if you're okay with it. So first
That's
of all,
okay.
I'm gonna have ID 1519. So I'm gonna have ID, age, gender, and then so I'm gonna go in and do a find function just as best practice. I'm gonna close it out now. And then so okay, so I'm gonna find ID, age, gender, and then and so I'll locate column 2, which is where ages are, and set it larger than 15. Older? Did you say you need to be strictly older than 15?
No. Yeah, let's do older and equal. That's okay. That's okay.
Okay. and I'm gonna do ID. Professor, if you're wondering why I'm not copying and pasting, it's because I literally cannot, because I'm
Yeah, I remember that. Yeah.
And then close it out, and then we're gonna do smaller equals to 19. And I'm gonna run that very quickly.
I think you need more parentheses. Yeah.
Yep.
Yep. No. Yeah. In MATLAB put it for you already.
Yeah. Okay. Like, yeah. Put it for me already. Okay. Cool.
Right.
So I have those. So I'm gonna have ID 15, 19 information, and then I'm gonna call it ID, age, gender, and then do ID 15, 19, which effectively what it does, it's okay, all those rows, and then loops through the entire table and pull out the information from the identified ID. And here.
Yep. Do you agree, guys? Make sense? 1 minute to copy. Give me 1 second, please. Okay, guys, sorry for that. Do you agree? Do you understand the process? Okay, now what I will do is I will use a couple of yeah, okay, so this is good. So let me do a couple of things here. What I will do is I will use this part here. Okay, we'll just copy this. Oh, well, I don't need to do that. And I will simply call directly info. And you're gonna see what happened. So take a look to the idea here, guys. It is, okay, from ID gender, find these positions, you agree? So these are the conditions that are satisfied. But you see that this one here, all this part here gives me the positions, right? What I can do is I can simply link this part here. So what I'm saying is the following. What I'm saying is the following. From ID gender, select this. This is going to give me the rows, right, guys? Guys, you agree? Take a look. This provides me the rows 2, 4, and 7. And what I want is I need to be sure is where's my mouse only? Yeah, comma, everything, I think. Yeah, something like that. You see in a single round? So these are the definition of my rows, are simply conditions. Find from ID gender, select the rows from ID gender that satisfy these conditions, and then provide me with all rows. Make sense? And then we should obtain, oh no, where's my, no, don't tell me.
Professor, wouldn't it be better to just code it separately anyway, since if it's one line is too long coding wise, then that'd be slightly confusing.
Yeah, but but the thing is, I want to show you that you can do this indeed in a single line. Give me 1 second. Yeah, now should do it. You see? So the nesting works in a very nice way. So these are my rows. The definition of my rows are based on conditionals. And this is my definition of my column, and then that's it. Make sense? So you can nest code in a very elegant way. Okay, so who wants to do the second one? Who wants to do this?
I can take a stab at this one.
Jack, perfect.
Sure.
Okay, Jack, so all yours.
Gotcha. Okay, so well, it's too bad we can't copy and paste. Let's see. No, actually, oh.
Yeah, you can name it as you want. Yeah. Oh, copy all.
Yeah.
Yeah. Try. Yeah.
Okay. Let's see.
Oh, it worked. Yeah.
Okay.
Good. Yeah.
Yeah, you just gotta highlight it, I guess.
Yeah.
Okay. So we're looking for individual with okay, less than 3, greater than 5. So we change the column we want to look at to 1.
Yep.
Greater than or equal to, well, change it to the 15 to a 3.
Yep. Mm-hmm.
And this again to a 1. Greater than or equal to 5.
Yep. Can you change the name of the matrix so we don't delete the previous one? So just put it.
Oh,
ID.
yes.
Yeah.
Yes.
Yeah.
Okay. I'll just do ID 3 and 5.
Yeah. Yeah. Something like that.
There you go.
And then you return everything. Yeah.
Okay. That should be good. Oh.
Okay. So what happened?
Let's see.
Okay. So this is debugging, guys. So what you can do is just try to understand what happens in the between. So you copy this part here and analyze this part here. Let's do it, because that's something that we're always going to do. Okay, let's find the problem there. What is the problem? Yeah, just copy that part down there and see what is this providing to you. Yeah, little more, one more, I think. Yeah, one more parenthesis or no, yeah, okay. No, just that part. So what you need to see is because remember, there is something apparently this is not providing you with any positions, right? Apparently that's happening.
Right.
You click here because this is going to give you the rows that satisfy these 2 conditions, right?
Okay.
Okay, just enter. Says empty. So why is empty?
Does it say we're not getting any rows?
Yes,
or,
but we know that let me see this one here. So you know that this one here, let's be sure that we haven't done anything. So what we want is, okay, so let's do this part here. Normally, this is what we do, guys, when something is missing. And I like this example just to show you. If something is wrong, no, I don't want to run this part here. So what I want to see is what happens, for example, if I apply only this part here. Agree? Yeah, I have the position 1, 2, and 3. So now what happens if I do this one here? What do you think is the problem? So remember that this one here, okay, so is this the problem? Take a look. Of course, later, guys, you're going to identify easily the problem. Oh, sorry.
the find.
I delete the find. Find. Yeah, I think it's okay. So the 2 components are correct. So what is the missing part then? What is at the wrong side? Is that this condition, guys, finding something that is smaller than 3 and finding something that is larger than 5 is a logical impossibility. Do you agree? So what you need to do here is basically OR. Okay, so you want values that are smaller than 3 or larger than 5. Make sense?
Okay, I see.
Yeah, and then basically now you are going to see what is the main equation? This one here. So what you only need to change is this one here and here we go. Make sense?
Gotcha. Okay. Yep.
Okay. So and that guys is something that you are going to be working with always is the logical. Just trying to debug your program and see what is the problem. Just try to decompose You identify where should be it, and then you decompose the pieces. It's the best way. And then if the pieces work, okay, the connector should be it. Make sense? Great, thank you. Okay, so who wants to do the last one? Yeah, who wants to find? No, this is not the one.
I can do it.
Yeah, give me 1 second. Yeah, let me see which one. This one. Yeah, perfect. Yep, who wants to do this?
I can do it, Jameson.
Yep. Here you go, Jameson. All yours. Yep. Can you have the control?
But I can't see your Zoom.
Yeah.
Oh, sorry, I got minimized.
Yep. Perfect, yeah. Mm-hmm. Yep. Okay. Makes sense to you guys? So what he's doing is, this is my matrix, and then my rows are going to satisfy certain condition, and then I print the age and what is that? And gender. Oh, yeah, if I want only gender, it's easy, right? If I just want gender, it's simply this. That's good. Perfect. Excellent. Okay, guys, easy. It is easy, right? Okay, so we're going to do the second assignment at the end of the class. So you have the second assignment. Can you verify that you have the second assignment, please? I send you, I think, on Monday.
Professor, we have a second one, but when you're gonna go over the first one?
Oh yeah, but wait. No, we are. I will not go over the first one. I will do the graphs, and then we are going to review this later. I want you to see the graphs first.
Okay, so let's stop graphs. Okay, cool.
Yes, yeah, exactly. The financial side of graphs. Yes, let's move a little more, okay? And perhaps half an hour, and then I do the graphs, and then we do more exercises, and then we continue moving. Okay, guys. So what we are going to be doing now. So let me clear my command so I can clear my command window. So now what we are going to be doing, guys, is a basic linear algebra. Okay, very basic, just to understand how linear algebra works and how MATLAB thinks, because the basics of MATLAB, guys, even for the engineering side of the equation, it is a matrix algebra. Okay, so this is the core of MATLAB, and the same happens with R and with the Python and all these big programs. So and that's of course the main issue with Excel, guys, because Excel doesn't think in terms of matrices. You know that, have you tried to do an inverse in Excel, an inverse of a matrix in Excel? It is a pain. Why? Because Excel works with cells. So it works, identifies a cell, but cannot do matrices. Okay, so it is very hard for Excel to do optimizations and all this stuff. So that's why there is programs, special programs, R, Excel, R, MATLAB, etc. That they use Excel, they use R, for example, to do some specific programs that are not able to be done by Excel, and then return the returns into Excel. So, and that's the beauty also about these programs, is the matrix algebra. So as I mentioned to you guys, we at this point know how to write a matrix. So what I can do is, for example, I will do a very dummy matrix. Okay, so this is a 3x3 matrix. Do you agree? How do you see the dimensions? What do we use to see the dimensions of this one here? What command do I use?
Size.
Right. Size of A is going to tell me it's a 3x3. Got it? If I want to know the length, remember length give you the largest dimension. In this case, well, it's gonna give you the same. Then you have it. Got it? Now, there is sometimes, guys, we want this to be vectorialized. So I want to convert this one into matrix. So the first row, sorry, you cannot do this. The first column, the second column goes below, the third column goes below. Okay, so normally you want to do this type of arrangement. So you want to have a big column matrix. So what I can do for that is simply, I will call A1, and I will call this A. This is called vectorializing a matrix. You see? So what I've done is I have put first column below the first column, second column below the first and second, the third column. This is what you have. Now, how do you recompose the matrix? I want this guy to, using A1, I want you to move, guys, this into the original A. How do you recompose this one? What do you use? You remember, there is one command function that we have used. If I want to reshape something, what command do I use?
You transpose.
No, if I transpose, so okay, let's assume that you assume this is transpose. What it changes is that all the columns, all the rows moves in a single column. So it doesn't work. Do you remember that reshape command, guys? We have done that before. So what we can do is I want to reshape these 3 columns, 3 rows. Take a look. So how the reshape works is very important for you. So reshape works 1, 2, 3. So it says, okay, how many rows and columns I will have? 3 and 3. So the multiplication of this one, 3 times 3, should be equal to the number of observations here. And of course, we have 9 observations. And then what it will do is we do blocks. So this is my first block. This is my first column. This is my second column, and this is my third column. So the inverse of a vec function, or vectorializing a function, is a reshape command. So it simply moves back into original position. Okay, so now I want, guys, you to do, A3. The last column want to be the first, second column the second, and the first column to be the last. Okay, so you do this. I want you to basically move left to right, or right to left. How do you do that?
You put A2.
What is it? Yeah, A2, can be A2, right?
A2, parentheses, colon, and then you specify, I did end, colon,
Yeah.
-1 to -2 to 1.
Yeah. Do you agree with that, guys, or not? Guys, you agree? So I want to keep the same order of my rows. What I want to change is simply the columns. So if you do this, you have this one here. Okay, there is a special command, let's call this A3B1, that is called flip left to right of A2. And that's exactly the same. What is interesting, guys, is you can do this by yourselves, but there is a MATLAB command that is called flip left to right that does exactly the same. Now, can you create A4 using A2, okay? I want the last row to be the first row, second row, the second, and first row, the last row. Very quickly, guys. Okay, so how do we do that? A2. In this case, what I want to change is the number of rows, the rows, right? So I want rows from n to -1, decreasing by 1 up to 1, and then all columns. Do you agree? So there is another way of doing this stuff also, guys. Let's call this A to B1. That is simply flip up and down the matrix that you want. Okay, we're gonna create our own flip up and downs very quickly, very soon. Okay, guys, now what I want from you is the following. Please join A. Join matrix A with first and third column of A4. So let's call this A5, okay? So let's call this A5. And let's do A6. And I just want to be rows 1 and 2. From A5. I want A7. Oh. I want to delete to column 3 from A6. Okay. Okay, 2 minutes to do this.
Professor,
Yes.
can you repeat what you want for A5?
A5.
Oh, sorry,
Yes.
sorry, for A6. For A6.
Yeah, A6 is, I just want, oh yeah, select the rows from my A5. You have built A5, and then just select rows 1 and 2 from A5.
Oh, okay, okay.
Okay. Sorry, A7. Okay, with that, I think we're more ready to move. ¿Cuánto tiempo tienen para hacer? 2 horas. Usted puede ir comiendo. No tengo break. Yo acabo a las 8:30. 8:15. No, no comí. 8:15 comió. ¿Cómo nomás ustedes, hijo, después? ¿Ya? Francisco, acaba tus tareas, por favor. One more minute, guys, and then we start. Ready? Okay, so let's do this very quickly. So A5 is going to be simply, I will join A, and close to this one, I will join A4. What I want from A4, I want columns, all rows, columns, what's that? 1 and 3. Do you agree, guys? Guys, you agree?
I mean, yeah, I mean, Professor, you could just have concatenated it, but that works too.
Yeah, but remember that concatenate is more R prone. In MATLAB, it's simpler. That's one of the advantages of MATLAB. Well, it is not significant, but you can do this very simply. Okay, you can do the horizontal concatenate or vertical concatenate. Make sense? Do you agree with that, guys? Okay, so A6 now is, once you have A5, A6 is simply going to be rows 1 and 2 from A5. So it's going to be basically A5. And from here, I just want rows 1 and 2, all columns. Now A7, no, A6, no, what's that? Oh yeah, A6 again. This is the way you delete columns, guys. From A6, all rows, column 3. Okay, I want this to be empty. So this is the way in which you delete, but be careful here, guys, that when you delete, you delete. Okay, so you cannot recover this matrix anymore, unless you have saved it in a different matrix. Do you agree? So if you do that, take a look. So all these column 3 and 6 disappear from my column here. Yeah, makes sense? Now what we can do is, they say A7 is going to be vectorialized A6. So how do we make this a column? Simply like that. I know why is it taking time. No. You see? So first column, second column down, third column down, fourth column down. I will give you an Excel template, guys, and you're gonna see how all this works beautifully. Now, how do I recover back to A7? So I need to do the reshape. I need to use data from A7. How many rows and how many columns? Because I want to recover the first one, right? Oopsie. Just give me 1 minute. tareas? No. Primero sus tareas. Mamá dice que apague la cocina. Okay. Francisco, ¿has hecho tus tareas? Entonces haz tus tareas. ¿Cómo te pones a jugar sin hacer tareas? Okay, guys, questions? No questions? Okay, so there are a couple of other commands. For example, we can have A9. There's going to be the diag, and we're going to use this all the time when we do some more advanced mathematics. Diagonal of a matrix simply provides you the main elements, the main diagonal elements of the matrix. You see, 1, 5, and 9. But also diagonal guys can create, so imagine A10. I want to do a diagonal with the following numbers, 3, 4, and 5. No. Let me see. Why this is not? Yeah, what I can do is I can create A equals 1 to 5. And I want to do diagonal of A. Yes. Okay, so if you have a series of numbers, when you use diagonal command to a series of numbers, what it does, it creates a matrix the same dimension as A, the length of A, and a square matrix. So it puts the numbers in a diagonal, in the main diagonal. Right? You're gonna see the use of this in very soon, guys. Yeah, I think that we are ready to do some programs now. Good. Okay, questions up to now? Yeah, let me see. You know, before moving to programs, and I prefer to check the plots that we haven't done. Okay. Yeah, let's talk about the amortization plots. Do you remember the amortization tables, guys, that we did? So this is a review of the class that didn't appear the graphs. Okay, I will do this very quickly, 15 minutes maximum. Do you remember, guys, the amortization table? Do you remember that? Yes or no? Yes. Okay. Unfortunately, I think I need to create everything because I don't have the data.
I mean, Professor, in the homework, you quite frankly just told us to load IBM.dat.
What? Sorry.
In the homework, you said to just load IBM.dat from the MATLAB.
Oh yeah, but I cannot do the MATLAB. No, I cannot do your homework. I need to do an example. So you know what? Let's do the amortizations very quickly, and the graphs with amortization, etc. So let's assume, guys, you know, an annual rate. Let's say that my annual rate equals, I don't know what I use, 0.05. Okay. Let's assume that, well, I need to compute my monthly rate. So how do you compute my monthly rate? Do you remember? It's going to be 1 plus the annual rate to the power 1 over 12 minus 1. Do you agree, guys? Do you agree? So if this is my annual rate, this is my monthly rate, and I need to enter my number of periods. I can call it, these are names, guys, so you can say whatever. So we can have, for example, 10 years, monthly payments. Then what I need is the loan amount. Yeah, I can call it just loan. Let's assume loan is $500,000. I have now all the ingredients, right? Yes, I have everything. So I need to simply, let's call principal, interest, then we have the balance and payment. Okay, and my command is going to be amortize. What I want to amortize, I need to enter first the monthly rate. I need the number of periods. I need the loan amount. Correct? And we are going to learn to do this type of programs. Oh, yeah, I didn't want to print everything. Make sense? So what I can do is I can call this a more table. I will create, this is a table, okay? And my table is going to be equal to my balance transposed, because my balance is aligned. I want like that. I want my interest also transposed. And I want my principal transposed. Well, perhaps I can do the number of periods. So how many years do we have? I can do 1, 2, how many periods I said, guys? 10 years, 120, right?
I think you said 30 years.
Oh, 30 years I've done here. No, for this particular example, number of periods equals 1. No, 10 years for this particular example.
Okay, okay.
Okay. So I have, yeah, 1 to 120, so we can take a look. Here we go. Oh, yeah, I need to add the payment vector. Yeah, the problem with the payment, guys, is that payment is a single number, you see? If I want to include this payment into this table here, what I will do is I will create, I think I created what is called a payment vector. So this is going to be simply a red mat of payment. I want 120,1. And now I can create my complete amortization table that is going to be basically this one here. Make sense? Perfect. So now what I will do, guys, is I will create what is a simple plot. Okay, this is called the amortization plots. Okay, so what are the amortization plots? We're going to learn some things here. So we're going to plot the balance. And I will call, what is this, if I write B here, what is the meaning of B? You remember? What is that?
Blue.
Blue, exactly. So what I'm saying is please plot balance and color it blue. Okay, if you do that, you see my screen, my graph or not?
No.
Okay, so here is where I need to change this to be in here. Now?
Yep.
Okay, perfect. Okay, now I know for the recording for Friday, I need to do this stuff. Okay, so now what I will do is I want to add, guys, remember, if I want to create a new figure, I write figure, semicolon, and then appears a new figure. But I want to use the same figure to add more lines in this figure. So what I need to do, remember, is to do a hold on. Okay, hold on tells MATLAB, I want to continue using that one. Okay, so what I will do is I will copy this one here. And what I will do is I will do a cum sum. This is a cumulative sum of my principal. And I will color this one here black. I think I always do this black and lines like this. So if you do that, take a look to your graph. You see? So what I'm doing is I'm accumulating my loan. So what is the maximum loan value that I can get? $500,000, right? So I start from zero, but as soon as I start paying the principal, this goes up to $500,000. Now, what I will do is I don't need to type again, hold on. Hold on is going to be permanent until I do hold off. And then what I want to do is the same as this one here. But now I want the interest. And for the interest, I can simply say dots and red. Okay, so let's take a look to what happens. Oh my God, here we go. And then you can do, of course, guys, titles, legend, you can do the grid, you can do whatever you want. But this is the basic idea of this one here, guys. Makes sense for everyone? So this implies the following, guys, that the interest go decreasing, you see, and the capital payment, and the capital, of course, the capital goes increasing. And what is my blue? What was my blue? Oh, my blue is that the amount of money I owe, it starts decreasing in time, and then it goes to zero when I finish my debt. So this goes to zero, and my capital goes to 500, and this is the interest rate, guys, that you're going to be paying. Yes, Kevin.
Professor, can you do one with a stock example, because you never did one in the video because you had technical trouble in the middle of the video and you just never did it?
What with what?
With stock data.
Oh no, yes. This is only the balance sheet.
Yes,
sorry, not the balance sheet. Sorry, this is a payment schedule. Yes, we're gonna do. Yeah, let's do perhaps some figures with stock data. Yeah, we can do the high, low, close charts that are common. So let me move this. Everyone understands this. So this is the part that was not you couldn't see this part here in the video. Okay, the process was you saw this one here. So if you follow, guys, what you saw in the video, just click and type what I've done. You should be able to recreate the graph. Okay, so now let's go into some some common high, low, close plots. Okay, and for here, what I use normally, yeah, I can load. I load normally Disney, okay, because it works. Disney.mat. It's an example data set that we have. Okay, so what I will do is I will simply determine the size. I want to know. Let me see who's here. I don't remember who's here. Disney. Oh yes, I have here. This is what I want to use, guys. I want to use close, open, high, and low. Okay, this is what I want to do. And what I want to do is basically I want to know. Let's call I equals size of whatever of Disney's. Disney close, for example. So Disney close, and I want the number of rows. Okay, I have 782 rows. And what I will do is, guys, I will just draw not all the data set, but I just want to draw perhaps the last 50. So remember that the data comes oldest, newest. So newest is the bottom part of the equation of the column. What I want is simply to draw the high low, okay, of what I want to use. Let me see. So first is the open. This is open. And what I can do is I want you to start. So the size I 782 minus 50. I'm just drawing the last 50 observations up to 782. Then I want the second one is open, high, low, and close. Okay, so it's open. So I can copy all this part here. Okay, this is going to be 1. Yes, and then I can say this red or blue, whatever. Okay, so it is open, high, low, and close. Here we go. This is, let me put this big. So the way you read this one here is to the left is the open, the small bar. This is the close, the low, and the high. Make sense? So in this case, for example, the second one, the open was lower than the close, but the close was in between the high and the low. Got it? So these are bars that tells you what is the activity, what was the variability in the day, etc. What is the trend, etc. Make sense? Makes sense, guys? It's easy to create this graph. Now, let's load another one. Let's load IBM. Let's load IBM dot that. Okay, so I can call this one rows, columns, and equals the size of IBM. Okay, I have 453 observations. That's okay. For the Bollinger, I can do the same. The command for Bollinger is Bolling. Then what I want is IBM. Let me see which one is. It is open. I always forget this. It's open, high, low, and close. Okay, let's do on the close. IBM everything, comma 4. My moving averages are going to be 15. And the lags are going to be 0. So, and this is your Bollinger Bands, guys. So basically it computes the moving average of the last 15 days. Okay, this red line, you see that? And then computes the standard deviation, 2 standard deviations up and down. And this is the way you construct the Bollinger Bands. Make sense to you? And there are a lot of technicals based on this one here.
Professor, I probably really shouldn't be asking this because I work in the stock market, but why does bowling matter? It's just one of those things I never understood, because like, why does the graph itself matter?
Yeah, well, you know what? In technical analysis, the Bollinger Bands tells you simply, you see that the Bollinger Bands does this type here, closes and does this type thing. You see
Sure.
that the bands. Okay, so
Sure.
basically that's a metric of volatility. So when the market really goes very thin, perhaps in this part here, there is thin here, so you have less volatility. What is also interesting is if you just play, Kevin, with different 15, 24, 36, normally is what the people use, you can create MACDs. And just you can more or less forecast what is going to be the trend on the Bollinger Bands. And also the other thing that they say is that if the Bollinger Bands, if the data, is approaching the external Bollinger Bands, so the most likely there's going to be a trend down. So for example, this one here, well, in this case, it trended down, but it didn't break. So it continues a trend up. And you see that this blue is almost in the line, is aligned with the upper Bollinger Band. So this is giving you a sense, it still is giving you a signal that, you know what, most likely the probability of going down is higher than the probability of going up. And so, and you can see, of course, it tells you that, but it doesn't tell you necessarily when it's going to break. So, well, here, and then we break down a little. This goes up again. The blue is very close to the kind of orange. So the probability of having a drop down is higher. You have a drop. And then the same here, but you can see here, that's the beauty here. So that's why you need to use different moving averages. This one here tells you, hey, you know what? You're very close to break, but nothing happens. You're very close to break, nothing happens. And then here, boom, you have something and then breaks like that. And you know, I'm not a very fan of Bollinger Bands. I'm more a fan of MACDs, exponential moving averages. You know, but in any case, remember that the technicals help a little, but fundamentals also make their game.
Got it.
Okay, guys. I think that's all what we did, no? Yep, I think that's it. Do you have more questions, guys, about this? Let's do, you know what? Give me your exercise number 1, sorry, homework number 1 and homework number 2 by next Monday. Okay, so both. No, actually, we're going to have coming also homework number 3 coming. So you need to, you know, 1 and 2 are going to be for Monday, guys, and 3 is going to be for Wednesday. Okay, so we need to catch up with assignments. Number 2, let's go and review number 2. Do you have your assignments number 2? So let me check. Where do I have that? Second assignment, here we go. Yeah, this is supposed to be work. We are going to work a little about this in a class, but do you see, let me share my screen. Do you see my screen? This is the second assignment. Do you see my screen, guys?
Yeah, I see it.
Okay, so it's very easy. You see, I am giving you ID, age, gender, and I just want you to find a bunch of things here. Now, then you do the price of a bond. We have done this last class, and just make some comparisons there. This is working with strings, and you're going to see something here. This is something where it's going to be a challenge for everyone. You just read, is create a code that you just need to. So this is interesting. For example, okay, let me explain this one here. So imagine, and actually, guys, this was used in, I think this was the First or Second World War. I don't remember. But the thing is that the basic of cryptography. So you have hello, got it? And then you attach to each of the letters a code, a number, got it? So if you want to say hello and no one to understand that one, you simply say, you know, in MATLAB, remember, I can do G1 plus 5. So because every single number is a number, every single string or letter is a number. And then if you do G1 equals G plus 5, no, and then you set a string G1. So what you have is this one here, MIQQT. So no one knows what is this one here. You see that? The only way in which you can recover the actual code is if you know this number. You agree with me, guys? So basically, if I tell you 5, I tell you plus 5 or something like that, you know that I need to do the reverse. I create a new variable G3 that is simply G2 minus 5. And then I do set a string G3. And then I go back with my hello. Of course, you can do very fancy equations here. You can do a quadratic. You can do whatever you want. Got it? And then you're going to mix up all this part here and create something that is completely, you know, impossible to understand. And what you need to do is we are going to try to solve this riddle, but you're going to give us a solution at the end, and then we're going to see the answer. And try to solve the riddle, guys. It will take you years to solve the riddle, even though it's a very simple one. Got it? Makes sense. So this is this last part here. These two are a very simple one. Questions?
Professor, can you explain the random like letters? Like how did that, the M and the
this one?
Yeah, the MJ and the QQT. Like
oh yeah. So let's take a look to this one here. Let's write in MATLAB hello. Okay, where is MATLAB? Let's write hello. So G is hello. Do you agree? So what I will create is G1 equals G plus 5. Do you see what it has done? So H is going to be then 104. the MATLAB code, the ASCII code for H is going to be 104. Plus 5 is 109. Do you agree? Do you see
Yeah,
that?
that makes sense.
Okay, now let's do G2. What I wrote here. Let's copy this one. Set a string G1. So what I'm doing is I'm transforming the numbers into letters, you see? So now 109 in a string is M. 106 transformed into string is J, etc. You see that? So if you receive a message like that, you have no idea what the other guy is telling to you. Make sense? Jack, makes sense. So you don't know what this guy is telling to you. So what the challenge for you is just try to, guys, don't overcomplicate it. I remember having one student that did a quadratic multiplied by something. So it was such a complex code that no one was able to solve it. Just add and subtract numbers. And if you can try to see what your friend is telling to you. At the end of the day, you give us a code. So the code for you is simply this one here, right? If I give you guys my code is going to be deciphered with a factor of +5. So you know that in order to decipher this one here, you do G2 is going to be G1 minus 5. And no, not minus 1. G1 minus 5. And then what you do is set a string of G2. And then you get your hello. Make sense?
Yeah, thank you.
Perfect. Yeah, okay. So questions, guys? Yeah, we're gonna have some time to work on this for a couple of minutes, but I want you, let's move into M code. Okay, so so let's start talking now about coding, programs, I mean. Now guys, when we want to do, what we have been doing, we have been working the command window, right? So once you close MATLAB, then you have the memory, but you don't have the line of command. And it's very tricky to work on the command window if you want to do a program. The command window is more for testing and for running, right? The way in which we create programs is called an M file. Okay, and what is an M file, guys? An M file is simply, it's a white document that has the following things. You have outputs. So you can have here. Do you remember when we have the balance? It was I don't remember. Investment. No, sorry, it was principal. Remember, it was principal. I think it was interest, and it was payments. Something like that. So this is the outputs. So this program here is going to return something. Okay, and then the outputs you put equals and the name of the program. In general, guys, this name should be equal to the file name. I recommend you this just for consistency. Okay, so if your program is called example, when you save the program, normally call it example.m. All right, just to keep consistency. And here, what you do is you put inputs. So remember in the amortize command, we had interest, we had number of periods, and then we have the principal. Do you agree? So in this one here, this is the name. All these ones are the inputs. And all these ones are the outputs. Okay, now for MATLAB guys to run the names, so when I call amortize, for example, the names doesn't matter. So I can call this X, Y, and Z. Of course, X represents interest, N represents number of, Y represents number of periods, and Z represents principal. So the names here, when you call the program, doesn't matter. They don't need to match exactly the names that you have in the program. However, the positions matter. So what I mean is, imagine that indeed this one here corresponds to interest rates, and this one here corresponds to N, right? But what if you made a mistake and then you say, you know what, okay, amortize, and then you simply shift the variables? There is no way in which MATLAB is going to recognize this one here as N and this one as the interest. For MATLAB, this one here is going to be the interest, this one here is going to be the N, so it's going to be a mess. Got it? So positions matter, names doesn't matter. The same here, you can call this one here if you want A, B, and C, it doesn't matter. But you need to know that A corresponds to the principal, B corresponds to the interest, and C corresponds to the payments. Got it? So names don't matter when you call the program. So this is when calling the program. Okay, so let's go. So what is interesting, guys, and then you have here commands, okay, list of commands. You do, and also here you can call other programs. So what you can do, and we're going to learn that, you can call, for example, another M program. And this one can call another program. And then this one can return something here, and this one can return something here. So this is a modular way of programming in MATLAB, R, Python, etc. This is very comfortable. Okay, so in order to have a clean program, guys, you don't want to be a huge program. It's much better sometimes that there is a repetitive program that you can remove, put as an independent program, and you call it when needed, right? We're going to learn all this stuff soon, guys. But questions about how the M files works in general, it's very simple. Okay, so let's do one example. Let me go back to MATLAB. So the way you create a new script, guys, you see my MATLAB?
Nope.
No. Now?
Yep.
Yep, okay, perfect. So now what I will do is I will use more this part here. The way you create a new one, you just go new and opens a new file. Okay, do you remember the flip up, the flip up and down? Let's do this. This is very simple. Okay, so let's create our file, and I will be modifying the functions. So I will create a function. So you start with the word function, and let's do example flip up and down, for example. Okay, we'll call it 21. We'll call this 2021. So this is going to be my name. There is no inputs, there is no outputs. Okay, so this is the first one. I want to do a very simple one. When the first thing that you do, guys, normally is the following. You do, I know you do a brief description. This program replicates the MATLAB command flip up and down, for example. Okay? And then you can put whatever you want, guys. Author, Eric. You can do date, normally date, whatever. And then you describe description of the program, something like that. Do you remember when we did help something, guys? Do you remember when we do help? So for example, let's do help amortize. Take a look to what the help looks like. So all this part here has been written in this way here. So if someone does a help X flip up and down 2021, what this guy is going to see is this part here. Make sense? Okay, so when you don't have inputs or outputs, this implies, guys, that your inputs must be located in the main program. The input needs to be located here. So I will do my input. I want my input to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my input. I will do this just to show it. Okay, and you want to see why this is completely inefficient to have the data in the program. That's insane. Got it? So now what I want is to create. How do I will call this AUD, up and down. How do we create up and down? It's going to be A. Up and down implies rows, right? I need to change the rows. So I go n minus 1 to 1. All columns. So this is my flip up and down, and my flip left to right is going to be everything. This one here. Okay, copy, and then we're going to work more, and you're going to start creating your own programs. So, yeah, well, let's copy this. Save as. I will save it in a. Oh yeah, this is okay. Okay, so have you saved this one here? The way we run a program, guys, you run the program from a command window or you call it from a different place. Okay, so the way we do it, let's simply copy this one here and then simply run. Are you able to run, guys?
The entire function or just AUD and AOR?
What do you mean?
Like, do you want us to run like X? Okay, yeah, no,
This
got
one
it.
here. This one here. So you just, in order to run the program, guys, you simply type the name of the program. Okay, recommendation, guys, save this one here as the name of the file. You see, this is the name of the file. This is the name of the program. Now, guys, let's improve this model. Okay, so you know what I want? I don't want to enter my data in, I I don't want to enter the data in the program. So I want the data to be inputted from outside. Got it? So what you do simply, if you want to receive data from outside, you simply do A. So this implies that in order to run this program, you need to have a matrix A. And then let's comment this one here. Let me copy this. So you don't need any more the data inside. And all the remaining part is the same. And this model here is more flexible because what you do is, in order to run, first of all, you need to be sure that you have A. I have A, yes. So you want to run, where's my, I need to enter this one here, and you run it. Makes sense to you? Do you understand how to do this stuff? When you enter the input, if you don't, now you try now to run, guys, this without this one here. It's going to tell you where is my data? I don't have my data, right? So you need to first enter the data, and then that's it. Right? Can you create a matrix, guys? Let's call V. That is going to be simply 1, or let's say, 10, 11, 12, 13, 14, 15. So this is my matrix. And I want you to find the up and down. So if you want to do this one here, you can simply do this, right? That's what I was telling to you. So in your program, you can have a name A, but when you call the program, you can use whatever you want, right? And then here you go.
Prof, quick problem. When I try to run a function the way you said, it gave me an error. Function definition and not supported English context. Functions can only be created as a local or nested function.
Yeah. I think, you know what, perhaps you need to be sure that you are in the same directory that we're working. Just be sure about the directory where you have saved this program. And the second thing is that you need to verify that you have opened a new script. This one here. Sorry, when you do new, it's a script, not function. It's a script. You guys, are you able to run? Jack, Jameson, Ryan, are you able to run? Yep. Jameson and Ryan, what about you?
No, for me, it says too many input arguments.
Too many, where are you? Okay, so you know what I need to do is, I need to be sure that you understand and you can run this program, because if you are not able to run this program, guys, your life is going to be miserable. Okay, Jameson, can you, can you share your screen? Jameson, can you share your screen? Just show me your MATLAB. Let's take a look very quickly. You all help me, guys, on finding what is a mistake. Function, blah, 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 okay. Yeah, oh, wait a second. So you need to define, as soon as you don't have A, Jameson, you see, you need to define the A in the input. Go to the function X parentheses. You need to go up. No, to the top. No, not there. To the top function, yeah, to the end. Yes, parentheses A. So you need to, caps A, yes. So this is going to tell your program is that you need an input that is going to be called A, and this A is going to be this matrix here. So now you can go in the command window, type A. No. Before type A, big A, caps A, yeah. No, A, just A. I want to see if you have A. Yeah, you have it. So now you do copy X, flip up, copy the name with an A. Yeah, not B, yeah, exactly, run. Yes, you have it. Now you do with B. Yep, you have it. You see?
Yep,
so
thank you.
What is important, guys, is that the input, you need to have the input. If you don't have A in the program, so in row 7, before we define A, if you don't have this in the program, so you need to have this as an input, right? And the more realistic, guys, is that to have this as an input. Okay, guys, perfect. So now we'll go back to me.
I guess, Professor, I guess another way to say it, it is important to keep the function in its own file, isn't it? And just call it for
Yes.
not. Okay, got it. Yep.
Yes, exactly that. Yeah. Where's my MATLAB? Here we go. Yep. Everyone with me here? Okay, so now you know what I don't like from this one here is that the name, even though I have a B, my names appear to be A, U, up and down, and A, left and right. I don't want A, I want to have my own names. Got it? How do I do that? In that case, guys, you need to complete your program. So we can call this one as you want. So we can, well, no, not as we want. These ones here have the names that we're going to export to the other side. So this one here is going to be the first one. And this one here is going to be the other output. What I've done, what is my, this one? This one, you see? So now I have a complete program. This is my output. My output must be produced, and this name here should appear somewhere here. Agree? And then I have an input. Now, when I call this program, guys, okay, save this one here first, copy this one here just to be sure that we all have the same M file. Ready? So now if you want to call this program, guys, from your command window, you just copy this. I want to use B. And the names I want is, I want this to be called BUD, and I want this to be called BLR. LR. And then you run, and then you have the names that you want. You see, guys? Oh, yeah, you need to do semicolon here, otherwise it's going to be printing. So now you can run this again, and only will appear BUD and BLR. Make sense, guys?
Where am I putting a semicolon again?
Oh, if you don't put semicolon here, remember if you remove the semicolon, MATLAB is going to show the result of this one here. We don't want that. We simply do semicolon. Normally, and this is a good recommendation, guys, when you do a program, do the semicolon at the end. Otherwise, MATLAB is going to be printing like this. So you take a look, you see? Prints everything. And this uses RAM memory like nothing. It will, it will use all your RAM memory very quickly. So that's why when you have M code, better if you do semicolon. Okay. Okay, now you're going to do another program. A very simple program, guys. So I want you to create a program. Your function is going to be called, the name is going to be called my matrix sum. Okay, I want you to input two matrices. So this must be conformable. And then I want simply to return A plus B. So I want C equals this part here, and create a mini program. We're going to work with that. Create a new work file. Oh, no. Two more minutes, guys. Okay. So if you want your program to work, guys, you need an input of two matrices. I just call A and B, whatever. I will save this file. I need to save this one. Yeah. There you guys, I have two matrices. So I hope A and B are going to be two matrices, and I will report C. And C simply is going to be what equals A plus E. And then I semicolon just not to show. I will do this just to show it. Agree with me, guys?
Yep.
So let's create A and B. So let's create, for example, A equals 1, 2, 3, 4. And let's create B equals 11, 12, 13, 13, 14. Agree with me? So I have A, I have B. And then if I want to sum these two guys, I simply copy this one here. So remember that for matrix, for summing matrices, the matrices must be of the same dimension, right? Now, what happens if there's a crazy guy that simply enters B in the following way? Imagine 15, 16. Now, try to sum. So if you see B and you see A, they are not going to be able to be summed, correct? If you try to use your program, it's going to tell you, there's something wrong here, right? Now, it tells you something, guys. It tells you the arrays have incompatible sizes for this operation, okay? So, but what we can do is we can do also our own checks. So we can tell our programs to give the user an error message, got it? So for that, let's compute, let's first of all understand that determine the columns and rows, the rows and columns of A and B. So let's call this M, N, and this is going to be equal to size of A. And let's do the same for B. Okay. And then we're going to use an if command. We're going to discuss more about if commands, but just I will show you how to easily work. Check conformability. Okay. So my question is going to be the following, and you're going to understand. If M, is not equal to M1, or N is not equal to N1, okay, so what do? Let's send an error message. And the error message is going to be, for us, is going to be, for example, matrices are not conformable. And then we have an end. And if it passes the test, so it will do the CA plus B. Okay, so copy, and then I will explain you how this works.
Professor, shouldn't you put an n at the end of your function too, and not just within the loop that's within the function?
You mean in this, in if n, this one?
No, I'm talking about after the C.
No. MATLAB assumes that your function starts and ends when you end. That's it.
Okay.
You
Okay.
don't
So
need
it's
to
not
put,
like,
yeah. It's not
yeah,
like R. Do you remember in R we have we use curly brackets at the beginning, and then curly brackets at the
and
end.
return.
No.
Yeah. Got it.
Here now. When we are going to be doing nesting of functions, you're going to see how this works also. It's very nice. Okay, so let's try to run now our model with A and B that are not conformal. Oh, what do you mean? What? Oh, what? A1. Oh, this is not A1. This is A. Now we can save it.
Professor, it should be B because M1 size B,
Oh,
right?
yeah, yeah. Of course. Otherwise, always is going to be correct. That's right. Here we go. You see, appears my message now. Matrices are not conformable. You see? So that's the way, guys, that you check, and then you can tell whatever you want. You can send different messages to the user. Make sense? Okay, copy this one here, and I will show you how to basically edit and understand other programs, other programs that are already built in MATLAB. And this is something that we're going to be doing, guys, in research or in real life. What you try to do, you don't want to create all the files that are already created. So what you can do is you should be able to edit the files. Okay, and that's the advantage of R and MATLAB, and also Python, of course. They are kind of well, once you pay MATLAB, everything is open source. R, you don't pay anything; it's open source, and you can modify whatever you want as you want. Okay, copy, and then we do something more. Ready? So now let's edit something, some very simple function, guys. If you want to edit a function that exists already in MATLAB, so what you do is you simply do edit, and let's do edit flip up and down, for example. Here appears. You see? When you do edit a function, the function is going to appear like that. So this part here is that when you do help flip up and down, this is the part that's going to appear. Got it? Oh, yeah, they have fixed this one here already. Yeah.
Professor, I think this is one of those copyright protection thing.
Yeah.
Not edited. Yeah.
Yeah, but wait a second. No, here we go. Here's a flip. No, the flip is simply, yeah, this is stupid because the flip up and down, the previous version had this open. Yeah, it doesn't do anything. Well, okay. But at least you can, well, let's try to see another one. Let's try to edit then someone that I need, linspace. Okay, so let me see, edit linspace. Oh, this one is good. This one is good. So what I've done, guys, I want to edit linspace, and I want this one to show you something. Can you please type edit linspace?
Professor, I don't know about you, but I can't edit a list for some reason.
You cannot edit the lean space also?
I don't know why. Let me try again though. Let me restart MATLAB.
Yep. You should, because normally this is what works.
Never mind, it works. I just need to restart MATLAB.
Perfect.
One quick note though, wouldn't it be safer if we just copy link space out and call it something else instead of
Oh
just
yeah. Yeah, we're
directly
not.
as
Yes.
source file? Yeah.
Yeah. No, we are not going to modify this. No, we don't want that. Yes, if you want to modify this, guys, and I agree with Kevin, just name it as one and save it as a different file. Okay, we're not going to modify the program. So yeah.
kind of dangerous to be directly messing with it since if
Yeah.
you mess this one up, you also theoretically can mess like hundreds of other ones up.
Yep, that's right. Okay, guys. Okay, so the only thing that I want from you is do you remember linear space? Do you remember what it does? So linear space, for example, 1 to 200. If I do this, what it will create? Oh, lean space. Why is not doing now? Oh, sorry. 1 to 200 starting. Sorry, and then that's wrong. It's 1 comma 200. You see how many values it creates? 100. Do you agree? But also, if I want to have different values, I can write here. I want 100 values. Make sense to you? Or I have 200 values. You see, you're the one that determines how many values you want between 1 and 200. Correct, guys? You understand that? However, you have a default value here. Make sense? Okay, so take a look to the program. So linear space, you need to enter D1, you need to enter D2, and you need to enter N. Got it? However, N is not obligatory. However, if you as a client don't enter N, you are going to have a default value. Okay, and for that, guys, what happens is the following. What we do is normally the following. This command here, if, you see, we're going to discuss if, else, for loops, while loops in next class, okay? So when you say the if loop is the following, is if, else, and, okay? So nargin is number of arguments. So what it's telling you is, so number of arguments here, I have 1, 2, 3. You see that? So what it's saying here is if my number of arguments equals 2, so these two, assume immediately by default that n is 100.
Right, but Professor, that's just a trigger. How is that? I'm a little lost here.
That was one.
You said if can you go over again? NARGIN equals to n equals to 100. Can you go over again?
Yes,
I'm
yes,
just-
yes, yes, yes. So what it does is the following. So what it will do is, okay, narking implies count the number of arguments or the number of inputs, okay? Number of arguments in the input. This is the ways. N number are arguments in input. So basically what it will do, the program will count 1, 2, and 3. But sometimes you enter like this. Imagine that I can enter this, right? So the computer is going to compute, oh, you have 1 and 2 arguments. So here what the MATLAB is going to say, is the number of arguments equal to 2? Yes, because I have only 1 and 2. If this is true, what is going to happen, it will create immediately one n that is equal to 100. Make sense? Okay, now another thing that crazy people can do because they don't know the program, I can enter this 100.6, for example. You know that this is not possible. Okay, so what it will do, it will round, and this is what it's doing. It checks, is the number of arguments equal to? Imagine, no, because I have in this example, I have 1, 2, 3 arguments. So move to the else and asks, and we'll force n to be this one here. So imagine if I do this one here, 100.6. So take a look to what happens when I do this. You see, it tells, if I enter a string, it will transform first into a number. That's double. It transforms any string character into a number. And then I take the floor. So any number that is not an integer is going to be transformed like an integer. So this is what it's doing here. Make sense? And then you can read this here, guys, you know, is a scalar, not is a scalar. Simply what this does is the following. If it is not an scalar, so you can have any crazy stuff going on here. So for example, you enter ABC letters, okay? So it will make a message, you know what, sorry, you need to have scalar inputs. You see, that's what it does. And then you have the function here. You can take a look to how fancy is the function. You just play around with this stuff here. Make sense to everyone? So that's the way you edit, or you are at least are able to check how things work. So now let me create this one here. Okay, so let's call and link programs. Okay, let's do one very simple program. Let me show my screen, and you're gonna do this. Where is this one? So let's do just 2 programs, okay? One program, so you need to create program 1. So let's do example link 1.m, and we have a example link 1, link 1. Let's call it like that. Link 2.m, something like that. This one here, guys, it will, you know, it's going to report to me a matrix C. And C is going to be equal to example link 1. Example link 1. And then what I want here is perhaps a couple of matrices. Let me create something. Okay, and then what you want to do is you want to do first sum. Okay, and the sum is going to be C equals A plus B. You want to do the product, and the product is going to be A times B. And then you want to do I don't know, power. You know, sorry, B, C, D, E is going to be A dot to the power B. Okay, so check that size the matrices, sorry, this is dot. The matrices are conformable. Otherwise, error message. Okay, so you're basically this one here. Sorry, this one here should be. So my output should be indeed, guys, C, D, E. Okay. What I want from you is create example link 1, link 2. And the only thing that it will provide is E. E is going to be equal to, so example link 1, link 2. And what you need from here is matrix A and B. And then the only thing that you're going to do here is E equals A to the power of B. Okay? And the power here, okay, so do this first, do this one here independent. And then we are going to link. So later, the next step is we're going to do, the power is not going to be done here. In the next step, we want example link 1 to call example link 1, link 2. To produce, yes.
I'm supposed to, okay, yeah, no, you refined it, now it makes sense, yeah, because previously you just wrote C, you didn't write C, D, and E, that's always confused as an output for link 1, yeah, never mind.
Yep, okay, so first do these independent programs, guys. Just don't bother yourself, create 2 programs. Just do this part here, this is one program, do this another program. They are completely independent. Okay, they are completely independent. And then we're going to learn how to link them. You know how to check the matrices. You can use, of course, the example sum that we have used, and then just add a couple of other operations, and that's it. 5 minutes, guys, to do this too, and then we come back.
Professor, did you ever ask your TA about if it's possible to submit a final project in R or?
Yeah, they told me no because they are already in comps. I completely forgot to do that. I completely forgot to tell you that. Yeah, I have one that is in China. He didn't reply. I will follow up with them.
Please do. Thank you.
Yep. Okay, so how do I call it? How do I call it, guys? Link one? Example link one, right? It was something like that.
Yep.
Okay, so I have C, then I have D that was 8 element by element, B, and then I had E that was A element by element power B, and that's it, right? This is the one of the programs. Oh, what I've done. And what I will do is I will copy this part here. And I will create the neural functions link one, link two. I don't need this part here. The only thing that I need here is this part here. And the only part that this returns is this part here. Do you agree, guys? And we call this one. Okay, guys, are you with me? So I think we have A. Sorry. We have A and we have B. Yeah, I just want. Okay, so I want to eliminate third column, all rows of B. I can do that, right? I just want to have a 2 by 2. So what I'm doing is B, row 3, all columns equal to empty. That's it. So now I have a conformable matrix, so I can run this program here. Can you please verify that you can run? So you have C, that is the sum, D, that is a element by element product, and E, that is simply the power. Can you verify this, guys?
To not exactly use the sim A and B, but it works.
No, it doesn't. It works. The thing is that it works. Everyone?
Yeah, it works.
Yeah, it worked for me.
Great. Okay, guys. So now, can you run E, the other model, the other program? You know, it's simply the power. It works?
It also worked for me.
Great. Okay, Jameson, Brian, Kevin.
Yeah. We're
Why did yours produce results twice?
No, I haven't.
You didn't?
No, this is the previous program, and this is my program, this program.
Okay.
Okay, now you have done this, guys, and now what we're going to do is instead of doing this E here, okay, what I will do is I will call from link 1, so I will comment this out. And what I will do is I will call the new program. It's very simple. So you do E, and then you call, what is my program? What's the name of your program? And I will call this one here. And then I provide A and B, and that's it. So easy, you see? So what I'm saying is E is going to be computed using this program, but in order for this program to run, I need to input A and B. So what the program is going to do is going to find this program, it's going to find here. It will input these two numbers. The program is going to compute A power B and return E. And then, boom, done. You're not going to even realize about that. Take a look at how this works. So let's do this again. So let's copy, sorry, let's save. And here you go, the results. Okay, please be sure that it works, and then I will show you a couple of things that we need to learn. Works or not? So basically this part here works?
Yep.
Works.
Perfect.
Yep.
Perfect. Perfect. Okay, guys. So now, and with this, we can stop today because we have done very, very good. So there is something, guys, that is called debugging. Okay, sometimes you have a mistake and you don't know what's going on. So for example, let me do a stupid mistake somewhere. Yeah, perhaps I do something like that. A very stupid mistake, okay? Try to run. Oh, it did? Why it did it? I know what it has done, sorry. So it did. What can I do? A, B, yeah, something like that. Okay, let's run. You see, it tells me, hey, guys, you have a problem. Variable AB is not recognized line 16. So you go line 16 and then you see it. Okay, we are lucky that our program, guys, is a very small one. You know, sometimes the program is so complex that it has different links. And MATLAB is so smart. It's going to tell you line 16 on program A, line 12 on program B, et cetera, et cetera, et cetera. It will guide you, okay? But sometimes it is hard to grasp the idea. You see, where is the problem here? I don't understand that. And what you do normally, guys, is something that is called a debugging process, okay? So what is a debugging process? Is normally what you do is you click, okay, this is data, so I should not have a problem up to here. So if you want the program to stop here, you just do a box here, not box, red, just click in here next to the 12, appears a red dot, you see that? Guys, do you see that?
Yeah.
Yeah,
Yep.
okay, so now run the program. Again, you run. And so what the program does is it stops here. And then you can see, just put your cursor in on top of M. So you have M equals 2, N equals 2, etc. what is A, you see your A, you see your B, etc. And then you want to continue doing this, click now on 16. Let's continue, then you do continue here. You see in this part here, continue. Then I stop and see, and then I can realize, oh, I have my mistake here. I understand what's going on here. So I can do a plus. So I solve my mistake. So you save. And then what I will do, guys, is that perhaps you want to stop your program somewhere in the other program is going to be called. You see? So you just run. And then you see it is stopped. Just to show you that indeed we are in another program. It is stopped in the second program that we are linking, and then we can see where are we. You see that, guys? It's beautiful. This we're going to complicate our lives later, but if you understand the logic and the basics of these two examples, our life is going to be much simpler later. Make sense to you?
All good.
Perfect. Okay, guys. So we stop here today. We have done really good. On Friday, I will prepare, 1 hour and a half a program for you. I will be sure that we have all the graphs, that we have everything, so you can please replicate that. Work on exercise set number 1 and exercise set number 2, please. Okay, just start now because these two are going to be due on Monday, next Monday, before class. You need to send me before class. We are going to review very quickly on class, and then we continue moving on more stuff. Got it? Questions?
Just aware of the class, that's it.
Yep. Okay, questions, guys? Are we okay?
Professor, do you know when this video is going to be ready to?
Yeah, and you know what? They told me, well, I provided on Monday, and then they gave it, I think 1 more day, maximum Friday should be. I think so. Okay, perfect. Okay, guys, talk soon and have a nice weekend, and read the video or watch the video we're going to create on Friday and practice. This is a matter of just practicing. And now next week, we're going to start working with data sets, and we're going to see how easy works everything. Okay, if you understand that the example of a 2 by 6, it works with 1 million, whatever you want. It's exactly the same. Got it? Okay, guys, so talk soon and have a nice weekend. I just need to stay with Kevin. See you guys.
Thank you. Have a good night.
Take care. Bye-bye. Bye, guys.
Yeah, got a quick